All right, welcome back. Mr. P Helps with Calculus. This is Unit 2, day number 3. We're going to continue to explore the limit definition of a derivative. That's this, as we've talked about in the last video. And we're going to be able to use it to find the derivative when we're given some sort of value of x and the function itself. Now, the warm-up here that you just saw a second ago is actually kind of what this video is all about. So I'm actually going to go over it in its entirety. So we're being given a function, f of x is 3x minus 2, pretty basic equation. We're being told that x equals 1, and we're going to use this limit definition of a derivative to find our derivative, our slope in this case. All right, so it says that f of x plus h, so in this case we know x is 1, so that's really f of 1 plus h, minus f of x, which is 1, f of 1, over h. So that's where I got this red one. Now, how do I get this green one? This is probably the most confusing part. So what I'm going to do here to find f of 1 plus h, I'm going to take 1 plus h and I'm going to put it into our equation for x. Because it's like the x, it's f of x, but it's actually f of 1 plus h. So that's going to be 3 times 1 plus h minus 2, which you see here. I'm going to put this in brackets. Probably not necessary, but I'm going to do it anyway. And then it says minus f of a. Well, that's or f of x. That's really just the function itself. Since we know x is 1, we can just say 3 times 1 minus 2, which I have right here. And then over h. Remember, h is the distance between the 2 points. And we want to squeeze h down to 0 because that's where we're going to have our derivative. Our derivative means if we squeeze it down to 0, then that would be the derivative at that point x. All right, now it just takes a bunch of algebra work. I distribute here. It looks like I distribute here. That simplifies down to this once I've subtracted it. I know I kind of did multiple steps at once. Then I can cross out this, and this is minus 3. This is positive 3. They cancel each other out. We're left with just 3h over h. Yes, you must continue writing in limit notation. You cannot stop writing in limit notation. I know I've said this in previous videos, but I'm going to say it again. You can't do that until you're ready to substitute in. Once you've gotten to this point, well, here, I'm ready to start substituting 0 in for all the h's, which I know sounds silly because all the h's are gone, but I'm ready to put 0 in for all the h's, then I don't need to write it in limit notation anymore. And the answer just happens to be 3. There really is no work because obviously, no matter what it is, the 3 is going to always be the answer. So 3 is the slope in this case. All right, so let's look at another example. Now, once again, I suggest that you watch the last video as I explained where this formula comes from this diagram. Because remember, this is just the distance delta x. This could be any x. This would just be x plus delta x, comma. That would be the x value. And this point would be f of x. And this height would be f of x plus delta x. Right? And then we use the slope formula. We do y sub 2 minus y sub 1 and x sub 2 minus x sub 1. So when we do that, we get f of x plus delta x minus f of x over this, which is x plus delta x minus x. And then we can kind of simplify this down to the formula that you see right here. And then it ends up working. All right, so as I switch to the next question, we've got f of x equals 3x minus 2. We're going to use the limit definition of a derivative in order to solve this. We're going to plug x plus h right here in for this x, and do that to what gives us this. And then we plug x right here in for x and get this. And then I'm going to do my distributing 3 times x, 3 times h. And that's how I get to this line. And then I start crossing off things that can reduce it. So all the things that can cancel each other out. 3x minus 3x and negative 2 plus 2 cancel each other out. And you're left with just 3h over h. And of course, the h's cancel each other out because anything divided by itself is 0. And I'm left with just 3. All right, and the next example is a very similar process. Once again, we're doing the same things. Find the derivative of f of x. Different equation. So remember, we're going to put x plus h here and here for the first part. So notice what I've done. F of x plus h for both of these x's minus the function itself over h. And then a lot of it is just algebra work, as you can follow through. Same steps as I just did. What you're left with this, you just factor out the h, cross it out. And then once you're done that, you don't need to write limit notation anymore. Plug 0 in for h and solve. Looks like we get 6 times x minus 1, which equals 6x minus 1. So yeah, we don't have a value of x. It never said find it when x equals 5 or something like that. So yeah, we don't get the option to use that f of a minus a, f of x minus h. Instead of f of x minus h is f of a minus h. We don't get to use that one because we don't know what the a term is. So we're going to end up with an actual equation as our answer. And no matter what x is, we could put any value of x into 6x minus 1, and that will always be the slope at every single value of x. It'll always work. That's the brilliant thing about this equation. All right, same thing here with example number 3. We don't have an a term. We don't have an x equals 5 or an x equals 2 or an x equals 1. We're only given an f of x. So we don't have any number we can put in for x. So once again, we put x plus h here and here. And then we just copy it right here. That's f of x plus h minus f of x over h. Then, okay, this takes a lot of work. X plus h to the third power is going to give you a lot of terms. I think that's 6 terms. That's 1, 2, 3, 4, 5, 6 terms right there. X plus h is right there, minus x cubed and minus x. So yeah, it's a lot of steps, but a lot of it is going to cancel out, leaving you with this big long term that all has an h in it. So you can factor out that h to turn red into blue. Once you've done that, you've gotten rid of the indeterminate solution. So therefore, you're ready to plug in 0 into all of this. Plug 0 into this equation, and there's your answer, 3x squared plus 1. Yes, it's a lot of work. You will find an easier way to do this in the future, but I'm not going to get into that just yet. But yes, this limit definition of a derivative does work. All right, fourth and final example. So first thing I would do is I would change this square root of x to x to the 1/2 power. That is the exact same thing. Actually, you know what? I would always do that in questions when I'm using the rules, but not necessarily in this case. It says differentiate f of x equals square root of x minus 1, f of x equals 4x. Looks like I've changed the question on it here. 4 times, yeah, it looks like I just changed the question. I guess I scratched this out for some reason. So we changed the question to f of x equals 4x. That's 4 times x plus h. That's f of x plus h minus f of x over h. All right, distribute, cancel out. You're left with just 4, so therefore 4 is your solution. All right, that brings me to the conclusion of this video. Thanks again for watching, and I'll see you on the next one.